Welcome everyone to the last presentation. We have Sigurd explaining us how to do the LLM engineering within GitLab CI.
All right. Thanks everybody. And it seems like I'm almost closing the summit. So let's see if I can make it in time. All right. All right. So as you all probably know, large language models have demonstrated notable capabilities on a range of natural language tasks. Everybody's using kind of ChatGPT and the like, right? And so there's a history to all of that, obviously. So it's not come from nothing, but came from traditional NLP. Maybe some of you remember. And then there was deep learning also applied to NLP, which was a big milestone. And then LLMs emerged, and including a whole bag of tricks to make this all work and look so nice today. But there's still a gap between deep learning and NLP, I think. So it's an actual evolution. And this all enables advanced AI applications these days, which we're all benefiting from because we have natural language interfaces now to communicate and exchange ideas or get creative responses from the chatbots. So I'm sure you've all used LLMs these days for various kinds of tasks, and so they're quite useful, but also have some way to go still. And so despite all of this, I'd like to emphasize that LLM software, in the end, or applications that leverage LLMs, is just software, and it should be treated like this. So there's an LLM component, but there's lots of other pieces coming together that form the entire application. So in the end, it's just software engineering with a little bit of a here and there difference. And so why not just apply DevOps, as we hopefully all do for regular software, to LLM-infused or enhanced software as well? Because really, in the end, it's not special because there's some kind of AI involved, right? And so developers or LLM engineers typically use pre-trained proprietary or open access LLMs rather than building them from scratch. Because when you build from scratch, you need significant resources like compute and so on, tons of data, expertise also, by the way, for developing and training these models. And so this is just way too complicated and way too expensive for the majority of people. So the most common techniques to use LLMs in applications are based on prompt engineering. So you're kind of contextualizing the LLM to guide it towards the task that you're trying to solve. And so what you typically do in this case is create test cases, so kind of test-driven development. Then you engineer a prompt, then you evaluate it on a test set, maybe iterate a little bit, and then in the end you ship. Maybe it could be the whole application, or you just publish a prompt. Depends. And when you do that, very often you use centrally hosted LLMs like one from OpenAI or all kinds of vendors that exist. Could also be self-hosting, open weights LLMs, but the point is they're hosted centrally. And there is a little bit of an issue with that, I think, because you need to be able to self-host, maybe deploy with infrastructure as code, which is knowledge that some have, some don't, and you're operating infrastructure of some kind of services. And the average LLM engineer might not want to do it or not be able to do that. Also, I'm just looking at the wrong slide. You need to manage IAM and security, because maybe you don't want to give everybody in the world or within the company or within the team access to your LLM, because in the end, this is high resource service that costs money, and the more people just use it, the more it costs. And so because we're talking about DevOps, we're also using LLMs in CI/CD, right? So because we want to run a test suite against the same LLM that we try or develop on locally during CI. But there are additional challenges when making sure that only the right people who trigger the CI job can access the LLM, and the permissions are kind of mapped and blah, blah, blah. Like all kinds of complications arise with secret leakage if you do it wrong, or hard-coded secrets are not always so acceptable by the IT security folks and so on. So how do you do that well? And then your tests may be passing today and may fail tomorrow without touching code, perhaps, because the LLM service, when it's a central service, was updated, but nobody told you, right? So the URL is the same, and now it behaves differently than yesterday. So you actually have little control over the particular version or kind of deployment of the LLM when it's central. And say you would like to test the new LLM version because you're ambitious and you're eager to try out something. But then you need to contact the central hosting team and say, I want this, and can you please do this for me? And all that communication overhead, and I don't think this is very efficient. So remember, I said LLM-infused software is just software, and we're all experts and applying DevOps, of course, and so on. So why not treat this just like some kind of service as part of our DevOps workflow during CI? So at Siemens, as you know, I guess, we love GitLab and have this really amazing Code Siemens Common GitLab instance. And GitLab has a CI feature called CI services. I think it's not so well known, but it's maybe an underrated feature. So CI services runs auxiliary containers alongside the main CI job as part of the CI pipeline. And this is super useful for integration testing. And I'm not talking about AI right now. I'm just talking about an arbitrary piece of software for which you do integration testing. Like you might have a database that you want to test against, the real one, not a mocked or in-memory version of it, but the actual one, like Postgres, maybe a cache like Redis. Testing frameworks like Playwright, we heard from Elements, at least I remember, and so on, right? So you can serve or run these kinds of auxiliary containers as part of your CI job through CI services. It's all managed by GitLab CI. And this way you have a clean, isolated, self-contained CI job setup, which enhances developer experience and makes sure that your tests are actually passing on the real thing, or almost real thing. So I thought this one day, what's an LLM inference service? It's also a kind of service thing, right? But surprisingly, it seems like not so many people have thought about it like this. In fact, it's not much different from a database because it's a network accessible server. You send a request, get a response, happens to be related to AI, but like I said, it's not that special. How about simply running an LLM inference server as a CI service? Just like a database, it's something with AI. And I think it's a pretty obvious idea, but then I started looking into it and figured out, there's this, and we heard before also yesterday, I think, there's this Ollama server, which is really popular, a way of running local LLMs locally on your machine or on some self-managed machine. So I looked into Ollama and then explored running it on GitLab as a CI service and tried to scale it down, not such a big model because I'm just experimenting and we have shared CPU runners and such, and it was working. And then I wanted to switch to our really recent, amazing GPU runners, and boom, it didn't work. What is going on? And so it turned out GPUs weren't supported by CI services. So it seems like, I don't know if I'm the first one on this world using GitLab for this who has this idea, but apparently, since there are no GPUs, nobody has been able to use GPUs for CI services, and so nobody has been doing this. Right, and so maybe to extend this idea even a little bit more now, when you have an LLM-infused app, it's not just always the LLM server, but sometimes also a database when you think about RAG. So that sounds more familiar, right? And there are also open source vector databases that you can use for RAG. There happens to be one that extends Postgres, so all familiar toolstack called pgvector. So maybe in this kind of slightly extended example, we have Ollama and pgvector and can integration test an actual RAG application using just GitLab, no extra external services. Okay, so I said CI services didn't support GPUs. So, oh my God, this doesn't work. What are we going to do about it? And since we're at the open source summit, and I was already anticipating this coming up, I said, roll up the sleeves and get it in. GitLab is open source, right? And so as an empowered person, contributing to open source isn't such a big deal, and I got it in. So all of you now, and since now you know this can be done, you can use it if you have a GPU machine and deploy a runner on it, or maybe GitLab.com also has shared runners with GPU support, I'm not so sure. And this, by the way, was a good contributor experience, coming back to the other talk today. So it was pretty pleasant and didn't actually take too long to get in. Right, so now we have LLMs that can be served as a CI service with a GPU. So also the more real-world models can be used, not just the really tiny ones for experimentation. And that's pretty nice. Okay, and not just to pitch how I contributed to GitLab and blah, blah, I felt like maybe let's walk briefly through a quick demo. So like I said, RAG application is not the most minimal example. It's a little bit of a more real-world one where you have a server for LLM serving and a database. And let's build one really quickly, hopefully in the next 6 minutes. All right, for a quick recap, what does RAG look like? Essentially, a user sends a prompt to a RAG engine. The application then orchestrates 2 backends. You get relevant documents from the document store that have been indexed before and so on, so according to some relevancy metric. Then create a composite prompt, including the system instructions. You kind of tell the system, you're now an agent to help me with this and that problem, and here's some context. And please answer my question now. And then the LLM responds, and the response gets forwarded to the user. That's kind of how it works in essence, right? And it's not super complicated, at least to create a kind of MVP RAG system for the purpose of the talk, at least. And let's do it with Python. I think almost everybody knows that machine learning and Gen AI and all that is mostly being implemented in Python these days, and there's some really amazing libraries that make it relatively straightforward to do this. And one of them, at the key library, I think is LangChain, and then a couple of auxiliary tools. So if you create a Python project, roughly the skeleton looks like this in the file system. Not going into all the details, but this is what we're kind of going to build now. So let's begin and create a GitLab Q&A agent, because GitLab CI, I felt like maybe this is a good example. I want to ask things about GitLab. So we create a qa.py file and create a class. It's our client, sort of. And I have some class level constants, like what the model I want to use and what's the prompt. Okay, the prompt is composed of a system message and a user message. So the system message is something like, you're a technical assistant, blah, 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 help me with some GitLab stuff, and so on. Then the user prompt is, okay, here's the context, which I retrieved from the vector store, and this is my question now. Can you please answer it and be really accurate and guide a little bit, to not blah 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 too much, and be precise and factual and so on. Okay. Now we create a constructor. Say here is the retriever we're going to look at in a moment. This is the thing that gets the relevant documents from the vector store. And we're using Ollama. The URL can change. Locally, it's maybe localhost port something. And in CI, it's some other host name port something. And so this must be configurable. Okay. Let's look into this using LangChain. So we're using LangChain's expression language here, but there are several APIs how you can do that. It's based around the concept of runnables, but don't worry too much about it. There are essentially 2 things we need to populate. A question key, so basically get the question from the passed string that comes from the user, like this is my question, this is the question, we're just passing this through. And then we're populating the context. For that, we use the retriever, so this is LangChain syntax, and we're converting stuff that the retriever gives us and making it actual just a long string of context. Okay. Now we're passing this, basically a dict of 2 keys. We're passing this on, and we want to get the answer. So just passing it through and doing some juggling and whatever, crunching with LangChain, concatenating context, then passing it to the prompt. The prompt is templated, so it gets injected into the prompt template. Then we pass it to the chat Ollama client, which connects to the Ollama server we've configured. Also, maybe notably, I'm seeding it, so it's reproducible, at least as much as Ollama is able to be reproducible at this point. And pass the model I want to use and so on, and then parse the output from Ollama back to a string. And that's basically it. And so for evaluation purposes, because when you evaluate, sometimes you just don't want to evaluate the answer, but also the context, how relevant the context was that was retrieved and so on. We're also returning the context, so we need to also kind of pass this information through. All right, that's it. And now we have an ask method, the only public method this class has. So it accepts a question and returns the answer and the context, so a list of context documents. And that's basically it. All right, not so complicated. Oh, no, it's a bit at the top. Let's implement a document store, also a class, so to abstract a little bit. A document store, when it synchronizes data into the vector store, needs to index the data and chunk it and so on and embed it because it does semantic search on the data, so it needs a model. Here's the model. And then we have a constructor and a couple of public methods. Again, some configuration stuff. What's the URI of the database and some information, da-da-da. Okay, we kind of store it all, configure the different clients. LangChain has all of this figured out, just import it. Have a record manager, so we can also update the document store over time and remove some old documents, create new documents, update, whatever. Parse Markdown, because I'm just assuming that we're copying some Markdown files from the GitLab documentation on gitlab.com. Parsing it, synchronizing the data now to the vector store, implementing the method for it. So it receives a bunch of files as input and then puts this into the vector store. For this, we use a record manager. You can look up all the details, of course, on the LangChain documentation, index it, split the documents into chunks, then pass the record manager to add indices and ways to discover when a document was removed or changed or so. Pass a cleanup key, so we always want to do a full cleanup, so we don't have leftovers from before. And some source ID key, so it can identify what the original source of the document was, so the document file name in this case. Just a bunch of internals, and you can all just find this on the internet. And then finally, we have a method that returns the retriever, because the way it's implemented in LangChain, you can get a retriever from this vector store abstraction. Okay, I know I'm running out of time. Totally unexpected. Okay, so because all these modules were private, because we want to have a clear public API, now we're re-exporting the relevant identifiers that a user of the library shall use, so the document store and the Q&A agent, and then that's the document maybe we want to index and then ask questions by using context from this, copied from GitLab. I hope that's okay. And then just a bunch of PyTest configuration stuff. So like a CLI kind of, you can add to PyTest with custom flags. So the URL of Ollama server and the vector database URI. So you can parameterize your test run. And then a bunch of where's data. So we have the data dir, what's that relative to the test module. Then a bunch of fixtures, setting up the client for Ollama, setting up the client for our GitLab QA client. Pulling the models, because if the models aren't loaded, then there's nothing you can do. So we have an auto-run fixture that runs at the very beginning of the test suite and pulls the models. Ollama's clever. If it has the models, it just says they're there and skip, right? And then also synchronize the documents, because if the documents aren't in the database, then we cannot actually do rack. All that runs automatically at the beginning of the test. And then I have a couple of example test cases, like I instructed the model to say, I have no idea what you want, basically, for questions that are irrelevant. So, this is the other one, sorry. This is the one where it has an answer. So how can I create a GitLab project access token? I expect it knows. How can I rotate it? Which GitLab tier support project access token? I implement a test, and this is really trivial now. I say, ask this question, get the answer, and make sure it doesn't say, I don't know. Just, basic testing. You can do more fancy stuff. And then there is this other counterpart. It should say, I don't have an answer. Same thing, basically ask a bunch of questions, and it should say, I don't know. Yeah. And then you can do a proper evaluation using deep eval, for instance, and actually run a bunch of metrics on your evaluation. And so I'm going to skip this a little bit now for the sake of time. But you kind of get the idea, right? And so this is just GitLab, just Python, no external services, all open source, open weights. Thanks.
Thank you.